All right, let's dive into this incredible story of how we basically gave sight to machines. It's a journey that, it really starts with a simple, everyday observation that uncovers this massive, massive technological challenge.
Listen to that. That's a 3-year-old. Just effortlessly, instantly, she gets it. Not just the objects in the picture, but the story they're telling. It's something we all do without even thinking about it.
And that right there, that's the big question, isn't it? I mean, for all our amazing technology, we've sent people to the moon, we've built phones that talk to us. Why has this one thing, this simple act of seeing, been so incredibly hard for computers?
To really get to the bottom of this, we've got to grasp a simple but really profound idea: the difference between just collecting data and actually truly understanding it.
Think about it like this. A camera takes a picture. What's it doing? It's just turning light into a bunch of numbers, pixels. It doesn't actually see anything. It's kind of like the difference between hearing and listening. Taking a picture isn't seeing. Real sight, that's about understanding, and that happens in the brain.
So why do we care so much? Well, because our smartest machines are still, for all intents and purposes, blind. And that's a huge roadblock. Self-driving cars that can't tell a harmless paper bag from a big rock. Security cameras everywhere, but they can't tell you if a child is in danger. The potential here is just enormous, right? From medicine to protecting the environment. But it all comes down to solving this one problem of sight.
So what was the first attempt to fix this? Well, researchers hit a wall, a big one. And you can explain the whole problem with a simple house pet, the cat. Turns out, teaching a computer what a cat is way, way harder than you'd think.
The early thinking seemed logical enough. We'll just teach the computer with a set of rules. We'll define cat in math terms. It's got these shapes, these colors, these specific features. On paper, it sounds perfect.
But then, reality comes crashing in. What about a cat curled up into a little ball? Or one that's hiding behind a couch with just its tail sticking out? Or a cat in some ridiculous, goofy pose? The real world is just infinitely messy and varied. And a rigid set of rules? There's just no way it can cover every single possibility. So that approach was a total dead end.
So the whole rules idea was a bust. Researchers needed a revolution. And that revolution wasn't inspired by a better algorithm, it was inspired by biology. The big breakthrough came when they stopped asking how can we program a computer and started asking, wait a minute, how do we learn to see? I mean, think about it. Nobody sits a toddler down and gives them a PowerPoint presentation on what a cat is. They learn by seeing thousands and thousands and thousands of examples in the real world. A kid's eyes are like tiny cameras, taking a snapshot every 200 milliseconds. By the time they're 3, they've seen hundreds of millions of images. That's their training data.
And that insight, that's what sparked the ImageNet project back in 2007. The goal was to give a computer the same kind of vast visual childhood experience. So researchers downloaded nearly 1 billion images from the internet. Then they used this massive crowdsourcing effort, almost 50,000 people from all over the world, to meticulously label them all. The end result? This unprecedented data set of 15 million labeled images that they just gave away for free to any researcher who wanted it.
And just to put into perspective what they were trying to do here, you got to realize what they were up against. It took Mother Nature 540 million years to evolve the human visual system.
So to even try and replicate a tiny fraction of that, the ImageNet team started with this truly mind-boggling amount of raw data. Almost 1 billion images scraped from all across the internet.
And from all of that, they built a data set so deep that just for the category cat alone, they had over 62,000 photos. That is the insane scale of experience it takes to teach a machine what a cat really is.
But look, this massive data set, this giant library of images, it was only half of the revolution. All that data needed a brain to process it. And it just so happened that the perfect kind of algorithm was finally ready for its moment in the spotlight.
And that algorithm is called a convolutional neural network, or CNN. It's a type of AI that's literally modeled on the human brain with millions of digital neurons stacked in layers. Now, these things had been around for decades, but they were always starved for data. ImageNet was the perfect fuel, the massive visual experience this computer brain needed to finally, truly learn.
And this is the result. This is a huge leap forward. The computer isn't just spitting out nouns anymore. Man, elephant. It's creating a whole sentence. It's understanding the relationship between the objects. This is the very beginning of real comprehension.
Of course, it's not perfect. Not yet. It's still learning.
So if it hasn't seen enough pictures of a toothbrush, it might get confused and call it something it knows better, like a baseball bat. It's a funny mistake, but it really shows you that the system is learning from experience, just like we do.
And it also shows you how these systems work, right? They are what they eat. So if you feed a computer 62,000 pictures of cats, well, it can get a little bit of a cat bias. It starts seeing the pattern of a cat everywhere it looks.
So where do we go from here? We've gone from total blindness to naming objects to describing simple scenes. What's the next great frontier in giving sight to machines?
The computer might look at this picture and see a person and a cake. But what it doesn't see is the human story. It doesn't see the cultural context, that this is a special Easter cake. It doesn't see the personal story behind his favorite t-shirt. And most importantly, it doesn't see the emotion, just the pure joy on this boy's face. That, right there, that is the next mountain to climb, moving from just recognizing things to true human-level understanding.
But the future this technology opens up, it's truly inspiring. Imagine doctors with an extra set of tireless microscopic eyes helping find diseases. Robots that can go into disaster zones to rescue people. AI that can help us discover new species or explore planets we can't even get to yet. This was never about replacing humans. It's about augmenting our own abilities.
And this really is the ultimate vision. It's a huge shift in how we think about technology. We are giving machines one of our most precious senses. And in return, they're not just going to see for us, they're going to help us see our own world in ways we never could before. For the first time ever, our eyes won't be the only ones exploring the universe. So what will we see differently now that we have help?